Hi everyone! This video is going to discuss about tutorial question gas. There are four basic assumptions about kinetic molecular theory of gas. The first one is related with the volume of the gas particle is negligible. Second, the intermolecular forces between the gas molecule are negligible. Third one is the average kinetic energy of the gas molecule is proportional to the temperature of the gas. Always must remember is absolute temperature. The unit mass in Kelvin. And then the last one is the collision between gas particles are elastic. So you can refer to these four basic assumptions in order to help you to answer tutorial question number 1.
Good day everyone. Okay, so learn 2A. State Boyle's law. Definition for Boyle's law is for a fixed amount of gas at a constant temperature, gas volume is inversely proportional to gas pressure. Okay, 2B. A sample of gas occupies a volume of 10 liter at the pressure of 2.0 atm. What would be the pressure of the gas if it is allowed to expand in a 50 liter container at the same temperature? So the formula for Boyle's law is P1 V1 equal to P2 V2. So P1 will be 2 and V1 will be 10. P2 we don't know and we need to find P2. V2 is 50. So P2 will be 0.4 atm. 3. State Charles law. For a fixed amount of gas at a constant pressure, the gas volume is directly proportional to the temperature in Kelvin. Okay, 3B question. A sample of gas occupies 100 ml at 25 degrees Celsius. What volume would the gas occupy at 32 degrees Celsius if the pressure remains constant? Okay, formula for Charles law is V1 over T1 equal to V2 over T2. So 100 ml 25 degrees Celsius convert to Kelvin. 25 plus 20 273 will be 298 Kelvin. 32 degrees Celsius convert to Kelvin. 32 plus 273 will be 305 Kelvin. So 100 over 298 equal to V over 305. So V would be 102.35 ml. Thank you.
Good evening. I want to discuss about tutorial chapter 5 question 4. The question is the density of gas X is 2.60 gram per liter at 25 Celsius and 101 kilopascal. What is the molecular mass of gas X? So the question is 1 mR. So we write down the question had given. Density is 2.6 gram per liter. Then the temperature is 25 Celsius. We need to change into Kelvin, so 25 Celsius plus 273.15 equal to 298.15 Kelvin. Then the pressure is 101 kilopascal. So we need to change it to the atm unit. So 101 times 10 power of 3 Pascal divided by 101.325 times 10 power of 3 Pascal. So we get the 0.9968 atm. For this question, we use this equation PV equal to nRT. So the N is equal to mass over molar mass. Then the V is we bring to the other side, so it's divided by. So mass over volume is the equal to density. So to the equation, we just substitute. The value of P is 0.9968 atm. The value for density is 2.6 gram per liter. R is constant, 0.08206 liter atm per mole per Kelvin times 298.15 Kelvin per molecular mass. So we just bring it to the side, then do the equation. 63.6121 gram per mole divided by 0.9968 atm. So we get 63.82 gram per mole.
Okay, saya akan terangkan soalan tutur chapter 5 nombor 5. Okay, first korang keluarkan maklumat yang diberi iaitu mass of empty glass is 134.74 gram and mass of glass plus gas Y 137.28 gram and mass of gas plus water is 1067.9 gram. And untuk cari mass of gas Y, kita tolak je mass of glass plus gas Y tolak dengan mass of empty glass, dapatlah mass of gas Y. And then mass of water, dan tolaklah mass of glass campur dengan water tolak dengan mass of empty. So dapatlah mass of water. So kalau pressure dia kena tukar kepada ATM, iaitu kena divide dengan 101,325. So dapatlah ATM. And then temperature, darjah Celsius kena tukar pada Kelvin. So campur dengan 273.15. And then soalan dia tanya pasal relative molecular mass of gas Y. So first cari volume of water. So guna formula density of water. And then masukkan maklumat iaitu mass of water 933.16 gram. And then density of water is 1 gram per milliliter. So dapatlah, lepas tu tukar kepada liter. And then volume of gas Y is equal to volume of glass and volume of water iaitu 0.9332 liter. And then from the ideal gas equation, kita masukkan formula. So kita nak cari molecular mass of gas Y. So masukkan formula mass iaitu 2.54 gram. And then R adalah constant iaitu 0.08206. And temperature adalah 304.15 Kelvin. And then pressure masukkan NV. Dan dapatlah molecular mass of gas Y dalam gram per mol. Thank you.
Hi, good evening. In this video, I will explain how to answer tutorial question chapter 5, number 6A and B. So for 6A, a sample of gas A weighing 40.5 gram occupies a volume of 15 liter at 25 degrees Celsius and 1.5 atm. Determine the molar mass of gas A. So from the question, the information that we get is this. So to find the molar mass of gas A, firstly, we have to find the mole of gas A. To find the mole of gas A, we are going to use this formula, PV equal to nRT. Just replace the information given into this formula, and at the end of the formula, we will get mole of gas A equal to 0.9196 mole. So to find the molar mass of gas A, the formula that we are going to use is N equal to mass over molar mass. Just replace the information given into this formula, and at the end of the working, we are going to get molar mass of gas A equal to 44.04 Gmol negative 1. For the next question, 6B, what is the volume of oxygen gas at STP required for the complete combustion of 10 liter of C2H4? So for the question, the information that we get is this. As we know, at STP, temperature equal to 0 degrees Celsius. When we convert into Kelvin, we will get 273.15 Kelvin. So to find the volume of O2, we have to find the mole of O2. So the first formula that we are going to use is PV equal to nRT. Just submit the information given into the formula, and then we will get the mole of C2H4 equal to 0.4461 mole. Next, we will write the equation, and then from the equation, we will use stoichiometry. 1 mole C2H4 equivalents to 3 mole O2. So at the end of the working, we will get 1.3883 mole of O2. Lastly, again, we will use stoichiometry. 1 mole O2 equivalents to 22.4 dm3. So lastly, at the end, we will get 29.98 dm3 of O2. This is the volume. Thank you.
Hello everyone, today I would like to explain about tutorial question 7a. State Dalton's law of partial pressure. The total pressure of mixture of non-reacting gases is the sum of the partial pressures exerted by each gases in the mixture. In a mixture of gases, each gas has a partial pressure, which is the hypothetical pressure of that gas if it alone occupied the volume of the mixture at the same temperature. For question B, a mixture of gas containing 2.45 gram of nitrogen, and 3.1 gram of neon occupies a volume of 2.5 liter. What is the pressure of the gas at 25 degrees Celsius? So we have to use the ideal gas equation. PV is equal to nRT. P is pressure, V is volume, N is the mole, R is the gas constant, and T is the temperature in Kelvin. So we have to find the mole of nitrogen. Mole of nitrogen is mass over molar mass, 2.45 over 28 gram of mole, and we will get 0.0875 mole of nitrogen. And for mole of neon, mass over molar mass, 3.1 gram over 20.2 gram over mole, we will get 0.1535 mole of neon. So we just substitute into the equation and we'll get pressure, volume 2.5 liter, mole, total mole 0.241, and then the gas constant of ATM is 0.08206, mole -1 and K -1, and then the temperature converted into the Kelvin to 98.15 Kelvin, and we'll get the answer 2.36 ATM. For question C, 4 liter of nitrogen at a pressure of 400 K -2 and 1 liter of argon at a pressure of 200 K -2 are transferred into a 2 liter container. Calculate the partial pressure of nitrogen. So for this part, we have to use the Boyle's law. P1 V1 is equal to P2 V2. So pressure of nitrogen is 400 and then the volume of nitrogen is 4. The pressure we have to find, and then the volume of the container is 2 liter. So we'll get 800 K -2 for the partial pressure of nitrogen. And the same goes to argon. P1 V1 is equal to P2 V2. 200 K -2 for argon pressure, and then 1 liter for volume of argon. P2 we have to find. 2 liter is the volume of container. So we'll get 100 K -2 for the partial pressure of argon. For part 3, the total pressure of the mixture is 800 plus with 100, we'll get 900 K -2 for the total pressure of the mixture.
Okay guys, jadi soalan yang saya dapat adalah soalan 8, tutorial chapter 5. So berdasarkan soalan, kita dapat informasi bahawa total partial pressure dia 762 mmHg, volume oksigen dia 128 ml. Ingat mililiter. Lepas tu suhu dia 297.15 Kelvin. Lepas tu partial pressure air dia 24 mmHg. Jadi berdasarkan formula partial pressure, total partial pressure sama dengan partial pressure oksigen tambah H2O, kita dapat tahu bahawa partial pressure oksigen adalah 738 mmHg. Lepas tu 738 mmHg kau bahagi dengan 760 constant tu untuk tukar mmHg tu kepada ATM. Jadi kau dapat 0.9711 ATM. Lepas tu dengan formula PV sama dengan nRT, kau dapat P dia 0.9711 ATM yang ni. Volume oksigen dia 128 ml, kau tukar jadi liter, jadi 0.128 liter sama dengan N bilangan mol sama dengan constant tu 0.08 bla bla bla, dengan suhu dia temperature 297.15 Kelvin. Lepas tu kau dapat bilangan mol dia 50976 darab 10 kuasa -3 mol. Lepas tu berdasarkan formula mol sama dengan molar mass, kau dapat mass oksigen tu 0.1631 gram. Thank you.
Hi, I'm Aisha from M1T1. So I got tutorial question number 9. So for A, describe the differences between the ideal gas and non-ideal gas behavior. So the answer is, the differences between the ideal and non-ideal behavior of gases are the intermolecular forces between gas molecules in ideal gas are negligible, while there are forces of attraction in real gas. So that is the point number 1. And the second point is, in ideal gas, the volume gas particles is negligible compared to the volume of its container. But in real gas, the molecules have certain volume. Okay, proceed to question 9b. What are the conditions at which real gases approach the ideal behavior? So there are two conditions. First, at low pressure, and second, at high temperature. At low pressure, when a gas is not compressed, the volume of container is increased. Gas molecules not occupy the sizable portion of the container. the distance between molecules gas is far away from each other, so the intermolecular forces is now become negligible. And at high temperature, when temperature increases, the kinetic energy of the gas molecules increases too. Therefore, the molecules have more energy to break away the intermolecular attractive force between them. So the intermolecular forces is now become negligible. That's all from me. Thank you.
Hello everyone, I will talk about phase change. So there are three states here: solid, liquid and gas. There are six phase changing process, which is vaporization, condensation, melting, freezing, sublimation and deposition. So the one in the blue pens is breakdown process and the one in the black pen is formation process. So for breakdown process, temperature is high, energy is high, kinetic energy increase, intermolecular force to hold the particle is low, movement molecule is high. So for formation process, temperature is low, energy is low, kinetic energy decrease, intermolecular force to hold the particle is high, and movement molecule is low. So for the example, solid to liquid is melting process. Melting process is a breakdown process. So when a solid substance is heat, so that means temperature is high. So when temperature is high, it gain energy. So energy is high, then kinetic energy increase. So when it increase, it vibrate more quickly and energetically. So intermolecular force to hold the particle is low because particle has enough energy to weaken the attractive force between themselves. So then particles are free to move. That's why movement molecules are high because they're free to move. Then that's how solid is changing into a liquid. Then for a liquid to solid, it's a freezing process. Freezing process is a formation process. So when the temperature of liquid is low, so it doesn't gain any energy, so energy is low. So kinetic energy is decreased. So when it decreases, particle vibrate at slower rate. So intermolecular force to hold the particle is high because intermolecular force are strong enough to hold the particle together in a phase and orderly arrangement. So movement molecules are low because they are held together, they hold together, so they doesn't move anywhere and doesn't give any move. So that's why movement molecules are low. So that's how liquid freeze become solid. Okay, that's it from me. Thank you.
Hope you all learned something. Thank you.